Hello, classmates! In this lesson, we will learn about the types and technical parameters of electrical equipment. In this lesson, we need to master the classification and basic rated parameters of electrical equipment in power plants and substations. Through this lesson, you will develop the ability to identify and analyze the types and rated parameters of electrical equipment. At the same time, we hope that through this lesson, we can further cultivate a sense of standardization, safety awareness, and a spirit of exploration, while improving self-control and management skills. The teaching focus of this lesson is the classification and basic rated parameters of electrical equipment in power plants and substations. The learning difficulty is analyzing the rated parameters of electrical equipment. First, let's look at Part 1: Primary electrical equipment. This refers to equipment that directly produces, converts, and transmits electrical energy. Therefore, it is called primary electrical equipment. There are mainly the following types. First, equipment that produces and converts electrical energy, such as generators, motors, and transformers. They are the most important electrical equipment that directly produces and converts electrical energy. Second, switching devices. These are devices that connect or disconnect circuits to meet operational or fault-handling needs, such as circuit breakers, disconnecting switches, contactors, and fuses. Third, protective devices, such as reactors used to limit short-circuit currents, and surge arresters, lightning rods, overhead ground wires used for overvoltage protection. Fourth, grounding safety devices. These are mainly used for working grounding to ensure the normal operation of the power system, or protective grounding to ensure personal safety. They are all connected to buried metal grounding electrodes or grounding grids. Fifth, current-carrying conductors. Electrical equipment must be connected through current-carrying conductors according to the sequence of production and distribution of electrical energy, or according to design requirements. Common current-carrying conductors include bus bars, overhead lines, and power cables. Sixth, instrument transformers, such as voltage transformers and current transformers. They transform high voltage and large current in the primary circuit into low voltage and low current for use by measuring instruments and relay protection devices. Seventh, compensation devices, such as synchronous condensers, power capacitors, arc suppression, coils, and shunt reactors. They are used to compensate for reactive power in the system, compensate for single-phase ground capacitive current in small current grounding systems, and absorb excess reactive power in the system, etc. Part 2: Secondary electrical equipment. Secondary electrical equipment refers to the 5 common types of equipment used for measuring, controlling, monitoring, and protecting primary electrical equipment. First, measuring instruments such as voltmeters, ammeters, wattmeters, and energy meters. They are used to measure the operating parameters of the primary circuit. Second, relay protection and automatic devices. They are used to quickly respond to electrical faults or abnormal operating conditions, and based on requirements, trip faults, issue signals, or make corresponding adjustments via relays. Third, DC equipment. DC equipment is mainly used to supply DC power for protection, operation, signals, and emergency lighting. They include DC generator sets, batteries, and rectifier devices. Fourth, control and signal equipment, as well as control cables. Control equipment refers to devices for manually or automatically opening and closing circuit breakers. Related signal equipment includes indicator panels, signals indicating the status of circuit breakers and disconnecting switches, and central signals in the main control room, etc. Fifth, insulation monitoring devices, used to monitor the insulation status of AC and DC systems. Years of teaching research have found that using secondary equipment to measure, control, monitor, and protect primary equipment is an important topic for improving safe and reliable operation. Improving electrical energy utilization rate using reactive power compensation technology, and research on optimization of auxiliary power rate for 2 by 660 megawatts thermal power units. We hope to optimize the selection of electrical equipment and their rated parameters in the design of different types of power line layouts. Part 3: Rated parameters of electrical equipment. 1. Rated voltage. This is the standard voltage level specified by the state based on the needs of national economic development, technical and economic rationality, and the manufacturing level of electrical equipment. Rated voltages in China are divided into 3 categories. The first category, 100 volts and below, mainly used for city lighting, batteries, etc. This is very familiar to everyone. The second category, voltages between 100 and 1000 volts, widely used in industrial and civilian low-voltage lighting, power, and control. The third category, voltages above 1000 volts, mainly used for generators, transformers, transmission and distribution lines, and high-voltage electrical equipment in power systems. The relationship between the rated voltages of various electrical equipment is as follows. The rated voltage of a generator equals 1.05 times the grid-rated voltage. 2. Rated current. This refers to the maximum current allowed to flow through the equipment for a long time under specified reference ambient temperature. Under these conditions, the maximum temperature of the equipment's insulation and current-carrying parts due to long-term heating must not exceed the specified allowable value. The reference ambient temperatures adopted in China are plus 40 degrees Celsius for electrical equipment and plus 25 degrees Celsius for conductors. 3. Rated capacity. This refers to the capacity indicated on the nameplate of a motor or electrical appliance that can operate continuously for a long time under rated working conditions. Usually, for transformers, it refers to apparent power. For motors, it refers to active power. For phase compensation equipment, it refers to apparent power or reactive power. The units are voltamperes, VA, kilovoltamperes, kVA, or megavoltamperes, MVA. Through the rated parameters of electrical equipment, we can reasonably select electrical equipment to form power lines, which must not only provide continuous and stable electrical energy to power users, but also ensure compliance with national standards, eliminate safety hazards, and develop a sense of standardization and safety. Well, Part 4 is review and reflection. For today's learning content, please use your after-class time to complete the following tasks. 1. What are the two main basic types of electrical equipment? What are their definitions? What specific equipment do they include? 2. What are the rated parameters of electrical equipment? 3. Refer to the power transformer model in the figure on the right and specify its rated parameters. That's all the content of this lesson. Thank you, everyone.